morning to everybody. My name is Lorenzo Bottai, and I work at the LAMMA consortium. The LAMMA is a consortium between the CNR and the Regione Toscana. I will present you a very operational project that we have carried on in last year for the Dipartimento di Regione Toscana Difesa del Suolo that work on several projects and several teams, in particular in protectional agency. So this is was very important for first estimation of the spreading of the fire, because last year, as you can see in this slide, was terrible here in Italy, and in particular also in Tuscany. I don't know if, yes, it's not so clear, but last year was a maximum of number of fire in the last 12 years, and as the hectares are quite huge, with 10 or 12 big fire, about 300 hectares for each event. That for Tuscany is very huge fires. The problem in Tuscany and also in the Mediterranean area was that forests are located, of course, in a rugged terrain with a steep slope. So a big problem is, of course, to estimate the surface, but this is the usual work, and also to collect data about destruction of facilities and houses infrastructure. But we want to focus also on some other themes that are shown in this picture, in particular in increasing of flooding risk and soil erosion and degradation, in particular for the increase of runoff, So for this we use a very simple model that was developed in a team that was composed by us, CNR IBIMET, and the University of Nice. And we use a very simple model that was developed under this kind of software that probably mostly of you know. Is it easy? But it's very simple, because the core of the model is the runoff module that you can find in several other open access software. But just to show some particular example. The essential input file of this model is, of course, the pre-file satellite image and post-file satellite image, and just these are highlighted items. It's the input file, and the other are calculated inside the algorithm. And we have developed also some HUDs in this model in order to use just satellite image, and as ancillary data just the digital elevation model. In terms that the land cover maps are substituted with some index that are calculated from the satellite image. I come back just with this kind of slide very shortly, because you have seen in several other presentations. In our labs we collect and we archive also the Sentinel, Sentinel 2A and B. We use and we substitute for the post-fire model. Originally we used the spot image and Landsat image, so we want to try to use the Sentinel. for, of course, all the consideration that we have started. Just to highlight the fact that is enhanced spatial resolution at 10 meters, and the revised periodicity that was 5 days, so very interesting updating the data. We collect the level 1C and level 2A that are shown in the slide, and for Tuscany region we archive 10 tiles that are described in this, and you see also this little picture that are one example of the central tile in Tuscany, the TPP tile, and this is a 1 year collection, and in practice we archive the 1C and 2B and 2A product, and we derive immediately 2 index, the NDVI and the NBR index, and so we have for each 5 days this kind of information adding to the original band. So during the year we have the NDVI and NBR collected in a sort of a multitemporal NDVI index and NBR index, and we compute exactly on downloading the image, not also this kind of index, but also the maximum volume composite of the index. So we have a sort of continuous updating of the maximum volume composite. We save it with the date of the acquisition. So at the end of the year we have one maximum volume composite for all the year, but you have also the maximum volume composite from the starting date of the year until the date of acquisition. In any case, when an event or fire event occurred, we make the analysis comparison with before and after the event, in the sense that we use NDVI and BR images, and we conduct with the post-fire or some other software the automatic burn area detected. For vegetation recovery, we plan to use this maximum volume composite and the after index in order to evaluate the level of the damage in terms of recover in index respect to the maximum volume composite. Some just example of the fire. This is near Florence, near Prato in particular. Is Montale is the place on the south part respected to the black fire, to the black scare that you can see in the image. And I put in evidence the band 8 and 12 that was used for the NBR index. And the first is on vegetation not affected by the fire with a typical signature. And the second one is inside a fire. So with automatic classification using the NDVI and the normalized difference between the pre-fire NDVI and post-fire NDVI, and the same with NBR index, we could easily detect the burn scare. For you can see the index before, and we can see in this picture the band that we used in order to calculate the NBR index, with the number of the band that was used, of course, even for the NBR and DVI index. Another very simple example, just to put in evidence that this natural phenomena is not so black and white situation. If you look at the transect that we put on outside the fire scare, And inside you can see in the green line the level of index without damage. The blue line is the NDVI index after the fire, and the red, of course, is the difference. So you can see that exactly on the border, you can see the is a sort of a fuzzy situation, in the sense that you can pass from no damage, of course, and the red line is equal to 0, with the increase of damage, with increase, of course, of the difference. This is quite the difference. It's not normalized in these cases. Just for an example, of course, this is the fire intensity. The sense of this picture is to put in evidence inside the burn scare that wasn't black and white. It's not a burn scare at all, but there are some differences inside that are not yet studied, but we think that of course there are several level of damage inside that could be used this kind of index to study this problem. To come back to the model that we used, the model I have a first part regard to the mapping scare, so I can go very short. This is a case study of Montale. There's a result of BART, no BART area in terms of black and transparent file. And the model needs to make some runoff initial file, so we make an infiltration reduction in fire scare. The rainfall depth are calculated, and we see how, and the runoff coefficient for land cover. Very shortly, I talk about at the beginning that we could substitute the land use land cover remapping with the runoff coefficient, with the NDVI runoff coefficient calculated with this kind of relationship. And we used, for this example, a rainfall depth about 55 millimeters for days. That is a typical precipitation with a return period of 2 years. So it's the maximum precipitation that we could have in future 2 years. And you can see what kind of runoff you obtain. This is the model of the Idrisi that calculate this kind of parameters. And we focus on runoff depth on mean discharge. That means it's just for in the first case you measure in millimeters. In the second case you measure in cubic meter per second. And this is, for example, the result of Montale fire or Montale fire scare. In the point that we show, I take just 6 points on the river discharge, and this is the results of the model. In these cases, the fire doesn't affect very much the runoff, because if you look at the ratio or at the percentage of the increase, is not so big difference, because the fire are probably distributed over a peak of the forest, a peak of the mountain, so it's not concentrated in one river basin, so are distributed the problem over several basins. And as a conclusion, we want to implement also the erosion part that are inside the post-fire model, that at the moment we doesn't apply in Tuscany because the coefficient was tested just in south part of the France. So we want to make some evaluation also of this part of the model. And probably the peak flow is more useful than the mean discharge, but we have to apply another model that are not included in Idrisi or other software. And as conclusion, we say that this kind of model provide estimation, of course, of band scale area, but is not so a big problem, this. But it's interesting for the runoff and soil erosion evaluation. Another interesting use of this model is the last point, so with this model it's possible to use and make evaluation of different scenarios, and also if you don't have a big fire but you want to protect some area, or you want to detect the increment of the runoff in particular area, you can do it with this model. So I finish.